Hey guys, welcome back to your lessons. It's me, Miss Moncrief. Hopefully my handwriting gets a little better than what you see right in this moment. All right, let's look at it. So today we're looking at lesson 2.6, which is just more on domain and range. Let's go through some of our vocabulary. Firstly, we have domain. Hopefully we all remember domain. We just talked about it. It was all possible input values for a function or what variable? It was x. This was also all x values. Now let's look at range. Range we also looked at recently. So range is all possible output values for a function, or in our case, what variable was it? Y. All right, a new one for you today, free of charge, is the discrete graph. So a discrete graph is separated by points. I like to think discrete dots. There will be no line connecting them. It's just a bunch of dots. All right, next we have a continuous graph. A continuous graph, it's a graph in which points are connected by a line. So you will see those dots that we sometimes plot connected, and that's what a continuous graph is. Next we have variable. Now we've been using variables for a really long time, but now we're going to apply them in word problems and stuff. So this is just a letter that represents an unknown value. So in a word problem, the variable answers the question. In most cases, you've seen the variable you guys know the most is x. X is always a variable. We can use any other letter to replace it, but that's just an example for you guys. All right, next, after variable, we have independent variable, which is a type of variable. Independent variables are an input. It causes the other variable to change. Now, we just said it was an input, and what was all inputs? They're x. So if you're ever looking at a graph and you need to figure out which one's independent, just look at the x-axis. And then the next one is our dependent variable. Our dependent variable is all outputs. It varies as a result and changes of the independent variable. So what was our output values? They were all y. So again, if you're ever looking at a graph and you need to know which one's dependent, look at the y-axis. So let's keep going. Let's look down at example 1. So the graph to the right shows orders placed for flowers at a florist. So the first question we want to ask, is this graph continuous or discrete? Now this takes one look at looking at the table, not the table, but at looking at the graph and seeing if there's a line connecting all of them. Is there a line connecting all of these? No, so this one is discrete. Remember, dots, discrete. Now, this is important to know. There's not a line because we don't care about all this in between. We don't care about the half days. We don't care about the 1.25 days. We don't care about 2.2 days. We just care about 1 day, 2 day, 3 day, and 4 day. That's all we care about. So we want to look at this. It says a table is a useful tool to organize data. So use the t-table. This is a t-table. To the right. Oh, just to right the ordered pairs from the graph. So all we're going to do is we have x, y ordered pairs like we normally do. And we're going to write those in the graph. So looking at my first dot, what is my x value? 1. And what's my y value? 2. All right, let's keep going. Second dot, what's my x value? 2. And what's my y value? 4. Third dot, what's my x value? 3. And what's my y value? 8. Fourth dot, what's my x value? 4. And what's my y value? 16. So we have 4 and 16. We know that all these, the x goes with the y next to it. So now we want to list the domain. Now, domain is something you know. Domain is all x values. So we remember writing domain, so like let's look at this one. If we were writing domain like we used to, what would we use? The first and last. We'd use our first x value, which was 1, and our last x value, which was 4. We'd put x in the middle, and less than or equal to, and less than or equal to. Now, this isn't what we're going to do here, because this is a discrete function. We don't write the domain and range like this for discrete functions. Because, like I said earlier, we don't care about all this in between. We just care about the 1 day, the 2 day, the 3 day, and the 4 day. We don't care about the 1.5 day. We don't care about the 3.75 day. We just care about 1, 2, 3, and 4. So when you have a discrete function, you'll just list your domain. So we'll start by putting braces. You list them in braces, and you'll just list them from least to greatest. So we have 1, 2, 3, and 4. Easy. 1, 2, 3, and 4. All right, and then the range that we talked about, finding range that way, but again, this one's discrete. We don't care about the half flower. Someone could have bought. We don't care about, you don't charge by a half of a flower, do you? No, you only charge by like a full flower order. So this is going to be, we're just going to do the same thing and list out like we have. Again, when you are writing your list, always write them least to greatest. So we have 2, 4, that looks like a 9. So we have 2, 4, 8, and 16. And that is my range. Oh, I still need something else right here. So, before we move on, anytime you have to write your domain and range like this, so like when you're typing it in for homework or when on a test or on a quiz, you always need to do one of two things. Write from least to greatest. So always write them least to greatest. And don't repeat numbers. So some of them you might see that they have double y values. Just write that number once. Don't type it in twice or anything like that. So now let's look at this and just talk about what's my independent and what's my dependent variable. So anytime you have time against something other than time, time is always going to be independent. Anytime you have time against something other than time, so we have days, which is a set of time, against flowers, we know that the days is going to be the independent variable. Now, don't rely on time always being independent, but when it's against something other than time, it will be. So we also always know that when we're looking at x and y graphs, we know that, we have x and y graphs, so the independent variable is so let's go back to my definitions. My independent variable is always my input, which is my x. So which one's my x? Number of days or number of flowers? You're right, it's going to be days. So x is my independent variable. So that leaves me with what's my dependent variable. So dependent was my output or my y, and flowers was my y. So y and flowers are my dependent variables. So also think of it in the fact that which one changed because of the other? Which one changed because of the other? Did the number of days change because of the number of flowers that were bought? Or did the number of flowers change because of the number of days? Well, it was definitely the number of flowers changed because of the number of days. Now we want to remember, does this graph represent a function? So we have two ways of remembering this. We can first go through the vertical line test. Does this pass the vertical line test? If we were to slide our pencil across this, would it ever repeat on an x value? No, it wouldn't. We can also look at our table. Do any of my x values repeat? No. So is this a function? Absolutely. Okay, now let's go into practicing finding independent and dependent variables when given word problems. So it says example 2, for each situation, identify the independent and dependent variables. So it says Susan is filling water bottles for a bicycle race. The number of water bottles she prepared is calculated based on how many hours she expects to be on course. So let W equal the number of water bottles Susan prepares, and H equal the number of hours Susan expects to be on the course. Now, we need to know which one's independent and which one's dependent. I said earlier, anytime you have time compared to something else, that's going to be our independent variable, so let's check. We have H. H represents hours. Hours is against W, which represents number of waters. So we have hours against time, so we have hours, which is time, against water, which is not. So we can go ahead and say that H is our independent variable. Now, if that still doesn't make sense, think of it this way. Which one changes because of the other? She said the number of bottles she prepared is calculated based on how many hours she expects to be on course. If she's on course for 3 hours, does that change how many water? If she's on course for 3 hours, does that change how many water bottles she's going to have if she was only on course for 1 hour? Yeah, so in this case, looking at it, think of what changes because of the other. So if H was independent, then dependent is W. All right, now we want to know which one represents the domain and which one represents the range. So the best thing I can tell you here is the independent variable will always represent our domain. The independent variable will always represent our domain. So our domain is also H. And the dependent variable will always represent our range. The dependent variable will always represent our range. So dependent is W, range is also W. Range is also W, which makes sense because let's go back to example 1 when we had a graph, and we can easily tell domain and range from a graph. My domain was what again? X, numbers of days. Which one did I list for the domain? Did I list number of flowers or the number of days? I list the number of days, right? So, and then thinking about the dependent variable, I said it was Y. Y was also my range, which is what I listed out for my range. All right, now let's go to B. B says the more time spent using social media, the more time people spend using social media, the less time they spend reading books. So we want R to equal the amount of time reading books and S to equal the amount of time on social media. So what's independent? Now, this one is what? This one, in this case, we have the amount of time reading, against the amount of time on social media. So we have time against time. It's not as easy to tell which one is independent. But, so let's go back to the other way of thinking. This one is, let's think of it this way. Which one changes because of the other? Does the time we spend using social media change because of the time we're reading? No, it says the more time people spend using social media, the less they spend reading. So, does the time people spend reading depend on how long they're on social media? Yeah, so in this case, S is going to be our independent variable, and r is going to be our dependent variable. Now again, which one's the domain? It's the same one as the independent variable. So s is also our domain. Which one's our range? The same one as the dependent variable, so r is our range. Alright, let's go look at a couple more things. Alright, now we want to recall function notation from lesson 2. So looking at g of x is equal to negative 3x plus 4, what is the name of the function? The name of the function is just g. It's just this lovely little letter that's in the front. So let's look past these two blanks and let's talk about what's going on here. So we were given g of negative 2. So negative 2 is on the inside of the parentheses. So is that an input or an output? You're right, it's an input. And if it's an input, we'll plug it in for x. So that's just what we did here. We did y is equal to negative 3 times negative 2 plus 4. So what is my output here? Well, let's solve negative 3 times negative 2 plus 4, which got us 10. So my output is going to be this y is equal to 10. My output is going to be this y is equal to 10. That is what we got after we found our input. Now let's look at the next part. It says the input is. Well, we got to figure that out real quick. So now we were given g of x is equal to 7. Now remember, these have the same function name, so we'll use that function. Is 7 on the inside of the parentheses? No. It's on the outside, so it's an output, so we'll plug it in outside of the equal sign. So we'll put 7 is equal to negative 3x plus 4 and then solve for x. The first step will be subtracting 4 and then dividing by 3, which will give us negative 1. So what is my output? What is my input from this? Because we were getting x in this case. My output is going to be x is equal to negative 1. So if we wanted to write our two solutions as ordered pairs, we could write the first one as negative 210 and the second one is negative 17. And these are both graphs these are both on the graph of this function right here. Alright, so now let's look at this. It says example 3, use the function to find the domain and range. You may use your calculator. I'm going to show you how to use your calculator. I'm also going to tell you how to do it otherwise. I'm not going to show you that part. There's not really a lot of room on the paper for it, but I am going to show you how to use the calculator. So this says find the domain of the function f of x is equal to negative x minus 10. Oh, that doesn't say find the domain, my bad. That says the domain of the function. F of x is equal to negative x minus 10 is negative 9, negative 8, negative 7, negative 6, negative 5. Find the range. We want to find the range. Now, they gave us the domain, so did they give us x or y? You're right, they gave us x. So these are all x values of this function right here. These are all x values of this function right here. I want to write that somewhere else. So, since they gave us all the x values, what are we trying to find? The y values. So, let's go to our handy dandy calculator. Okay, in your calculator, I want you to go to y equals. I want you to then type in our function, so negative x minus 10. Negative x minus 10. Now, I want to find a table, so hopefully you remember from older lessons to find the table, you will click second, the blue button, and graph, which will give us table. Now, what we want to do is look for these numbers in my x value, in my x on my x side of the table. So we want -9, -8, -7, -6, and -5. So go find -9. We'll start by finding -9. All right, so here we are. We have -9, -8, -7, -6, -5, -4. So once we found, well, we don't need -4. Once we found all of these, we're just going to list out our y values. We're just going to list out our y values. So, and just like earlier when I listed domain and range of a discrete function, I listed them from least to greatest. So all of our y values for this function will be -1, -2, -3, -4, and -5. So we need to start from least to greatest. And remember, it gets a little trickier when we're looking at negative numbers, so we need to find the one farthest from the 0, which would be -5. So we're going to start at -5. So we have -5, -4, -3, -2, and -1. And that's all my range values. We were looking on the y side and listing all of these, starting from least to greatest. Okay, so that one wasn't too bad. The biggest problem you're going to have here is actually listing them. But I think you'll learn better to use the calculator. Now, another thing you can do if you couldn't figure out how to use the calculator, let's go to a blank page. So we had f of x is equal to -x minus 10, and we wanted to find the range given the domain. Given the domain was -9, -8, -7, -6, and -5. What you could have done had you not been able to use the calculator is just plug all of these numbers in. So if we had f of -9, we'd have negative times -9 minus 10. Or f of -8, we'd have negative times -8 minus 10. F of -7 is equal to -7 minus 10. F of -6 is equal to -6 minus 10, and f of -5 is equal to -5 minus 10. So that would still get me -1, -2, -3, -4, and -5. It just would have been and then you would have just had to list them from here, which would still be -5, -4. List them from least to greatest here, which we would still start with -4 and go to -1. But that's what you can do if you can't use the table. So now let's look at the next one. We have the domain of the function g of x is equal to -2x plus 5 is -4 is less than x less than 2 integers, just integers. So we want to find the range. So we're looking from -4 to 2, just the integers. Just the integers. So that'll probably be along the lines of -4, -3, -2, and ... That's the numbers we're looking at. So again, did they give us the domain or the range? They gave us the domain, so we are looking for the range or the y. So everyone go to y. Let's do this in our calculator again. we are going to go to y equals, clear it out, and we have negative 2x plus 5. And now I want to find my table again. So second graph to get us the table. We are looking for the x values for the integers between negative 4 and 2. So let's go ahead and move this down some and see if I can get them all in the same spot. Yeah, I do. So we have negative 4, which is 13, or the y value for negative 4 is 13. The y value for negative 3 is 11, negative 2 is 9, negative 1 is 7, 0 is 5, 1 is 3, and 2 is 1. So we just want to list out these y values from negative 4 to 1 because we were looking at the integers. So remember, we also want to sort these from least to greatest. So what's going to be my first one? Hopefully you got it right and you said 1. So let's draw out my braces. So we are going to go 1, go up to 3, 5, 7, 9, 11, and lastly 13. And those are that is all my range. Just that right there. Alright, so the next one, we're switching it up. This time, it says the range of a function h of x is equal to 3x minus 9 is natural numbers that are multiples of 3. So natural numbers means we start where? We start at 1, 2, 3. But if they're multiples of 3, that means we start at 3. So we go 3, 6, 9. So we want to find the first 4 elements of the domain. So they gave us the range, which is the y. We need to find the domain, which is the x. So go back to your calculator. Go to y equals. And again, I'm still going to use this table. We're just going to clear it out. We now need to plug in 3x minus 9. And we now need to find a table. So click second graph to get a table. Now, do we need to be looking in the x? Do we need to start by looking in the x side of the table or the y side of the table? You guessed it right. We are trying to look at the x side of the table. We need to look at the y side of the table first because they gave us the range. So we are looking at natural numbers that are multiples of 3. So are natural numbers any of these negatives? No, so let's go all the way down to 0. Now, hold up, all the way down to 0. Now, is a 0 a natural number? No, so let's go ahead, skip a little bit of it so we can start with where we're at. So, after 0. Now we are only looking at multiples of 3. Lucky for us, these are all multiples of 3. 3 divided by 3 is 1. 6 divided by 3 is 2. These all are divisible by 3. So, we just need to list the first 4 elements. So, we need to list, going by this, what's my first one with 3? 4. What's my next one with 6? 5. My next one with 9 is 6. And my next one with 12 is 7. So, we are just going to use 4, 5, 6, and 7. 4, 5, 6, and 7. So list them from least to greatest. And 4, 5, 6, and 7. And remember, 4, 5, 6, and 7. So these aren't too bad. It's mostly looking at a table and trying to figure that out. And trying to look at where they meet up. If you wanted to look at this one without a table, so let's clear this out. So this time it was h of x is equal to 3x minus 9. Is equal to 3x minus 9. And it said that the range are all natural numbers that are multiples of 3. So it would have been 3, 6, 9, and 12 would have been our first ones. So 3, 6, 9, and 12. And since these are all range, so they're all outputs, they're all y's, we will set them equal to our equation and solve for x. But again, if I were you, I honestly would have just used the table. Much easier. Okay, let's move on to the next thing we have before I set you free to try a lot of this stuff on your own. So, this says the definition of a function is that each input has one output. So, we want to look at for each set, determine if it is a function, and then find the domain and range. If necessary, use a table or a mapping diagram to organize the data. I'm not going to do that with you guys. You guys saw in lesson 2.3 how to make mapping diagrams in a table. So, but we can just look at these numbers and see if they are functions or not. So, in order to first figure out if it's a function, we need to look at all my x values. So let's highlight all my x values in pink. Make it a little smaller. Make it a little bigger. So my first one is 3, 5, 7, 8, 11, 12, and 15. Those are all my x values. So are any of them the same? No, they're all extremely different numbers. So if they're all different, we know that this is in fact a function. Yes! No one's cheating. Remember the cheating metaphor in TikTok I hope you watched? Alright, now we just want to list the domain. This is not going to be like we did in 2.4. This is not going to be like we did in 2.4. We're just going to do the braces and list. So, make a brace and list it. List it from least to greatest. Least to greatest. List from least to greatest. Always list from least to greatest. So what's my smallest one? Alright, it's 3. Perfect. What's my next smallest one? 5. Ugh, even better. 7, 8, 11. Well, that was rude. 11, 12, and 15. And end your braces. Alright, now we want to list the range. I'm going to highlight the range all in, what's an extremely different color than pink? This blue. So I have 6, 7, 7, 9, 14, 6, and 7. Now this time we have a few repeats. Do I ever want to list my repeats? No. So let's underline all of our repeats. We have 6 and another 6. So how many times am I going to write 6, everybody? Once. Only once. Do not write it more than once. Once. Also, it's our smallest number, so we're going to write it first. What's my second number? 7. Let's see if we got any repeaters for 7. Oh, there's another one. Oh, and there's another one. So 7 repeats itself 3 times. How many times are we going to write it, ladies and gentlemen? That's right, once. Only write it once. If you write it more than once, it'll be wrong. So we have 6, and then 7. And then what comes next? All right, it looks like we have a 9. 9 doesn't repeat any, so we can just write it down. We don't have to make a big deal about them. And then we have 14. 14 also doesn't repeat any, so we don't have to make a big deal about them either. So, and that's all you do for listing your domain and range of ordered pairs. That's all you have to do for listing a domain and range for ordered pairs. So now let's go and look at B. I'm going to do the thing again where I highlight them. Ooh, this time I think I'm going to do orange. So let's highlight all of my x's before we deter. Let's highlight all of my x's to help us figure out if it's a function or not. So we got my first x is 0.3. My next x is 0.4. My third x is 0.3. And my last x is 0.5. Alright, so do we have any that repeat? Oh my gosh, we have 0.3 that repeats. But before we go ahead and determine definitely for a fact that it's not a function, let's look at the y's. Alright, 0.3 is dating 6. How sweet. 0.3 is also dating 7. How not sweet. They're dating two different people. So does that make it a function? No, that is no fun, not a function. Yep, I'm just going to roll with it, not a function. So, since we're already highlighted our x values, let's go ahead and write out our domain. Remember, we're just listing out these x values. We always list from what? From what? Least to greatest. Oh, I wish I hadn't highlighted in that. Okay, from least to greatest. From least to greatest. So, what is my smallest one? 0.3. And again, it's there twice because he's a cheater. Do we want to put 0.3 more than once? No, we don't. Put it down once. So we have 0.3. The next one, what's the next biggest? 0.4. Very good. Ooh, that should be a point, 0.4. And lastly, we have 0.5. Okay, now let's move on to the range. Let's highlight the range in a pretty color. We'll do blue. Get some Charger Spirit going on in here. So my first y value is 0.6. My next y value is 0.8, then 0.7, and 0.5. Again, we want to list the range from least to greatest. What is the smallest of these? Now, lately, we've been starting from the front. From the front, our first one was our smallest, but in this case, it's not. My smallest one is going to be this 0.5, so put the 0.5 down. My next one is going to be 0.6, then 0.7, and lastly 0.8. Alright, and that's all you got to do for listing your domain and range of sets of ordered pairs. That's all you got to do. And that is all for the lesson today. You do, in your lesson assignment, need to complete the practice. So that way your teacher, me, or Miss Hinson, or Miss Fleming, or Miss Mitchell, know where we can help you out. We can see what you've learned from this lesson. So you do need to complete those questions on your own. So I hope you do that. If you have any other questions, feel free to reach out to your teacher. This is what we're here for. And I hope you are having a fantastic, great day. Goodbye.